Hello, this is Patricia Kooijman of the Catalysis Institute at the University of Cape Town. This is a short tutorial on how to extract despacings from high-resolution transmission electron microscopy images using Fiji or ImageJ. First of all, of course, you'll have to download and install Fiji or ImageJ. If you haven't done that yet, you can find the software, for example, on this site, but there are many other places, proxy servers, where you can also find it. Once the software has been installed, what we need to do, of course, is open a data file. The example I'm treating here is for Gatan's digital micrograph version 4, but it's fairly easy to open almost any original microscopy image format using Fiji. When you open the file, you have to pay attention that you get this window which says Bioformat Import Options. And then the setting I've chosen here is just the standard ImageJ setting, which gives us this image. And if we look at what's at the top bar there in the image, we see that it's the software says that the area of view is 0.05 times 0.05 microns. Now, we don't really want microns because that's not accurate enough for atomic resolution imaging, so we choose Analyze Set Scale. Then we get this window where we see here that the unit of length is micron. We can change this to nanometer, but then we'll also have to change the known distance from 1 to 1000. Now, if we do that, we will see that actually the scale is a little bit more accurate than 0.05 micron, because it's 54.19 nanometers. And the software sees this from the metadata, which I will show in a moment. One thing we can do, although we don't need this to determine the despacings, but if you want to publish the image, you always need to add a scale bar, which you can find under Analyze Tools Scale Bar, and then you can choose how long you want the scale bar to be. In this case, I've chosen 5 nanometers, and we can set the thickness of the scale bar and the font size of the text that shows you the length of the scale bar. So this one is 5 nanometers here in the bottom right, as you see. So you can easily make a thicker bar or a longer bar, choose 10 nanometers, choose 1 nanometer, use a thicker font. You can use different colors if you want. As I mentioned, the Fiji software will grab the magnification from the metadata. So this is just the first part of the metadata. It's alphabetical, more or less. The first is some very important, at least for the software, information, and then after that it's alphabetical. And what you will see just below half of the list is the actual magnification. So if your microscope has been calibrated and the calibration magnifications have been entered properly into the microscope software, then Fiji will automatically read in the actual magnification, so the corrected calibrated magnification. So that's how you know that if your microscope calibration has been properly done, you will have really accurate data here. Which brings us to the actual dspace determination. First of all, in the Fiji menu, we select the rectangle tool. Then we select an area of the image, and we can force Fiji to select a square area, which is better for these analyses, by pressing the Shift key while dragging an area using the mouse. So we select a square area, and as you can see here, I selected an area that clearly has despacings present. then we go to Process and we choose the Fast Fourier Transform. Now, when we activate this, we get sort of an artificial diffraction pattern. And again here, because Fiji reads out these calibrated actual magnifications from the metadata, again it gives us the exact scale of this artificial diffraction pattern of the fast Fourier transform. So what we do now to accurately get the d-spacings, there are several ways of going about it, but I'll show you the easiest one, is we activate the zoom in, the magnifier in the Fiji menu. And then for this example, I've clicked twice, so I've done 2 steps in zoom in, and then we see this blown up diffraction pattern. And then with the mouse pointer, we can just set the mouse in the image on one of these dots, because that's one of the diffraction spots that gives you the d-spacing. And then what we will see in the Fiji menu at the top right here is that this distance, because it's always a distance from the center of the image, which is where those 2 vague horizontal and vertical lines meet, where you see a little bit of intensity, which is the center of the artificial diffraction pattern. You will see that this spot where the cross is marked here is 0.32 nanometers. So this actually just gives you your d-spacings. Another way to do this is to draw a circle, and to make sure that the circle is concentric around that cross of these 2 horizontal and vertical lines, and make sure that your circle exactly overlaps multiple diffraction spots. So that might increase your accuracy a little bit, but it also costs a lot more time than the method I've described here. And as you can see, there are spots at different distances, which means that this Fourier transform, this artificial diffraction pattern, contains information on multiple d-spacings from your structure. So you can obtain multiple d-spacings in one go using this procedure. Now, if we go back to the original image and we just zoom in once, so we click that little magnifier and then click in the image the same area that we used for the Fourier transform here to zoom in once, we get this image. And then if we want to increase the visibility of the structure, what we can do is go to Image, Adjust, and then choose Window/Level, which will give you this window. Then we can click Auto, and that will give you an image with a much increased contrast and brightness. And then if we look at roughly the same area that we used for the Fourier transform, you can clearly see that you don't only see lines here, which are d-spacings in one direction, but you actually see dots, which means that you actually see the individual atomic columns. And that was also already clear in the Fourier transform, because we clearly saw multiple d-spacing. So there are multiple directions, multiple repetitive directions in this area of the image. So this was a very brief tutorial on how to extract d-spacings from high resolution images. Thank you.